Effects of cannabis, Wikipedia audio. The effects of cannabis are caused by the chemical compounds in the plant, including cannabinoids, such as tetrahydrocannabinol, which is only one of more than 100 different cannabinoids present in the plant. Cannabis has various psychological and physiological effects on the human body. Different plants of the genus cannabis contain different and often unpredictable concentrations of THC and other cannabinoids and hundreds of other molecules that have a pharmacological effect, so that the final net effect cannot reliably be foreseen. Acute effects while under the influence can include euphoria and anxiety. Cannabidiol, another cannabinoid found in cannabis in varying amounts, has been shown to alleviate the adverse effects of THC that some consumers experience. With very high doses, THC can induce auditory and visual hallucinations. Efficacies. Research about medical benefits of cannabis has been hindered by United States federal law. Smoking any substance will carry about the same risk as smoking tobacco due to carcinogens in all smoke, and the ultimate conclusions on these factors are disputed. Cannabis use disorder is defined as a medical diagnosis in the 5th revision of the Diagnostic and Statistical Manual of Mental Disorders. The most prevalent psychoactive substances in cannabis are cannabinoids, most notably THC. Some varieties, having undergone careful selection and growing techniques, can yield as much as 29% THC. Another psychoactive cannabinoid present in cannabis sativa is tetrahydrocannabivarin, but it is only found in small amounts and is a cannabinoid antagonist. There are also similar compounds contained in cannabis that do not exhibit any psychoactive response but are obligatory for functionality. Cannabidiol, an isomer of THC, cannabivarin, an analog of cannabinol with a different side chain, cannabidivarin, an analog of CBD with a different side chain, and cannabinolic acid. How these other compounds interact with THC is not fully understood. Some clinical studies have proposed that CBD acts as a balancing force to regulate the strength of the psychoactive agent THC. CBD is also believed to regulate the body's metabolism of THC by inactivating cytochrome P450, an important class of enzymes that metabolize drugs. Experiments in which mice were treated with CBD followed by THC showed that CBD treatment was associated with a substantial increase in brain concentrations of THC and its major metabolites, most likely because it decreased the rate of clearance of THC from the body. Cannabis cofactor compounds have also been linked to lowering body temperature, modulating immune functioning, and cell protection. The essential oil of cannabis contains many fragrant terpenoids which may synergize with the cannabinoids to produce their unique effects. THC is converted rapidly to 11-hydroxy-THC, which is also pharmacologically active, so the drug effect outlasts measurable THC levels in blood. THC and cannabidiol are also neuroprotective antioxidants. Research in rats has indicated that THC prevented hydroperoxide-induced oxidative damage as well as or better than other antioxidants in a chemical system and neuronal cultures. Cannabidiol was significantly more protective than either vitamin E or vitamin C. The cannabinoid receptor is a typical member of the largest known family of receptors called a G-protein-coupled receptor. A signature of this type of receptor is the distinct pattern of how the receptor molecule spans the cell membrane 7 times. The location of cannabinoid receptors exists on the cell membrane, and both outside and inside the cell membrane. CB1 receptors, the bigger of the two, are extraordinarily abundant in the brain, 10 times more plentiful than mu-opioid receptors, the receptors responsible for the effects of morphine. CB2 receptors are structurally different, found only on cells of the immune system, and seems to function similarly to its CB1 counterpart. CB2 receptors are most commonly prevalent on B cells, natural killer cells, and monocytes, but can also be found on polymorphonuclear neutrophil cells, T8 cells, and T4 cells. In the tonsils, the CB2 receptors appear to be restricted to B lymphocyte-enriched areas. THC and its endogenous equivalent anandamide additionally interact with glycine receptors. Cannabinoids usually contain a 1,1-dimethylpyrin ring, a variedly derivatized aromatic ring and a variedly unsaturated cyclohexyl ring and their immediate chemical precursors, constituting a family of about 60 bicyclic and tricyclic compounds. Like most other neurological processes, the effects of cannabis on the brain follow the standard protocol of signal transduction, the electrochemical system of sending signals through neurons for a biological response. It is now understood that cannabinoid receptors appear in similar forms in most vertebrates and invertebrates and have a long evolutionary history of 500 million years. The binding of cannabinoids to cannabinoid receptors decrease adenylyl cyclase activity, inhibit calcium N channels, and disinhibit K and A channels. There are at least two types of cannabinoid receptors. The CB1 receptor is found primarily in the brain and mediates the psychological effects of THC. The CB2 receptor is most abundantly found on cells of the immune system. Cannabinoids act as immunomodulators at CB2 receptors, meaning they increase some immune responses and decrease others. For example, non-psychotropic cannabinoids can be used as a very effective anti-inflammatory. The affinity of cannabinoids to bind to either receptor is about the same, with only a slight increase observed with the plant-derived compound CBD binding to CB2 receptors more frequently. Cannabinoids likely have a role in the brain's control of movement and memory, as well as natural pain modulation. It is clear that cannabinoids can affect pain transmission and, specifically, that cannabinoids interact with the brain's endogenous opioid system and may affect dopamine transmission. Cannabinoids and cannabinoid receptors. Most cannabinoids are lipophilic compounds that are easily stored in fat, thus yielding a long elimination half-life relative to other recreational drugs. The THC molecule, and related compounds, are usually detectable in drug tests from 3 days up to 10 days according to Redwood Laboratories. Long-term users can produce positive tests for 2 to 3 months after ceasing cannabis use. No fatal overdoses with cannabis use have been reported as of 2006. A review published in the British Journal of Psychiatry in February 2008 said that no deaths directly due to acute cannabis use have ever been reported. THC, the principal psychoactive constituent of the cannabis plant, has an extremely low toxicity, and the amount that can enter the body through the consumption of cannabis plants poses no threat of death. In dogs, the minimum lethal dose of THC is over 3 g/kg. According to the Merck Index, the LD50 of THC is 1,270 mg/kg for male rats and 730 mg/kg for female rats from oral consumption in sesame oil, and 42 mg/kg for rats from inhalation. The ratio of cannabis material required to produce a fatal overdose to the amount required to saturate cannabinoid receptors and cause intoxication is approximately 40,000:1. It is important though to note that cannabinoids and other molecules present in cannabis can alter the metabolism of other drugs, especially due to competition for clearing metabolic pathways such as cytochrome CYP450, thus leading to drug toxicities by medications that the person consuming cannabis may be taking. A 2007 study found that while tobacco and cannabis smoke are quite similar, cannabis smoke contained higher amounts of ammonia, hydrogen cyanide, and nitrogen oxides, but lower levels of carcinogenic polycyclic aromatic hydrocarbons. This study found that directly inhaled cannabis smoke contained as much as 20 times as much ammonia and 5 times as much hydrogen cyanide as tobacco smoke, and compared the properties of both mainstream and sidestream smoke. Mainstream cannabis smoke was found to contain higher concentrations of selected polycyclic aromatic hydrocarbons than sidestream tobacco smoke. However, other studies have found much lower disparities in ammonia and hydrogen cyanide between cannabis and tobacco, and that some other constituents are either lower or non-existent in cannabis smoke. Biochemical mechanisms in the brain. Sustainability in the body. Cannabis smoke contains thousands of organic and inorganic chemical compounds. This tar is chemically similar to that found in tobacco smoke or cigars. Over 50 known carcinogens have been identified in cannabis smoke. These include nitrosamines, reactive aldehydes, and polycyclic hydrocarbons, including benzpyrene. Marijuana smoke was listed as a cancer agent in California in 2009. A study by the British Lung Foundation published in 2012 identifies cannabis smoke as a carcinogen and also finds awareness of the danger is low compared with the high awareness of the dangers of smoking tobacco, particularly among younger users. Other observations include possible increased risk from each cigarette, lack of research on the effect of cannabis smoke alone, low rate of addiction compared to tobacco, and episodic nature of cannabis use compared to steady frequent smoking of tobacco. Professor David Nutt, a UK drug expert, points out that the study cited by the British Lung Foundation has been accused of both false reasoning and incorrect methodology. Further, he notes that other studies have failed to connect cannabis with lung cancer, and accuses the BLF of scaremongering over cannabis. Toxicities related to cannabinoids. Related to smoking. Short-term effects. Psychological effects. When smoked, the short-term effects of cannabis manifest within seconds and are fully apparent within a few minutes, typically lasting for 1-3 hours, varying by the person and the strain of cannabis. After oral ingestion of cannabis, the onset of effect is delayed relative to smoking, taking 30 minutes to 2 hours, but the duration is prolonged due to continued slow absorption. The duration of noticeable effects has been observed to diminish due to prolonged, repeated use and the development of a tolerance to cannabinoids. The psychoactive effects of cannabis, known as a high, are subjective and can vary based on the person and the method of use. When THC enters the bloodstream and reaches the brain, it binds to cannabinoid receptors. The endogenous ligand of these receptors is anandamide, the effects of which THC emulates. This agonism of the cannabinoid receptors results in changes in the levels of various neurotransmitters, especially dopamine and norepinephrine, neurotransmitters which are closely associated with the acute effects of cannabis ingestion, such as euphoria and anxiety. Some effects may include a general alteration of conscious perception, euphoria, feelings of well-being, relaxation or stress reduction, increased appreciation of the arts, including humor and music, joviality, metacognition and introspection, enhanced recollection, increased sensuality, increased awareness of sensation, increased libido, and creativity. Abstract or philosophical thinking, disruption of linear memory and paranoia or anxiety are also typical. Anxiety is the most commonly reported side effect of smoking marijuana. Between 20 and 30% of recreational users experience intense anxiety and/or panic attacks after smoking cannabis. However, some report anxiety only after not smoking cannabis for a prolonged period of time. Inexperience and use in an unfamiliar environment are major contributing factors to this anxiety. Cannabidiol, another cannabinoid found in cannabis in varying amounts, has been shown to ameliorate the adverse effects of THC, including anxiety, that some consumers experience. Somatic effects. Cannabis also produces many subjective and highly tangible effects, such as greater enjoyment of food taste and aroma, an enhanced enjoyment of music and comedy, and marked distortions in the perception of time and space. At higher doses, effects can include altered body image, auditory and/or visual illusions, pseudo-hallucinations, and ataxia from selective impairment of polysynaptic reflexes. In some cases, cannabis can lead to dissociative states such as depersonalization and derealization. Any episode of acute psychosis that accompanies cannabis use usually abates after 6 hours, but in rare instances, heavy users may find the symptoms continuing for many days. If the episode is accompanied by aggression or sedation, physical restraint may be necessary. While many psychoactive drugs clearly fall into the category of either stimulant, depressant, or hallucinogen, cannabis exhibits a mix of all properties, perhaps leaning the most towards hallucinogenic or psychedelic properties, though with other effects quite pronounced as well. THC is typically considered the primary active component of the cannabis plant. Various scientific studies have suggested that certain other cannabinoids like CBD may also play a significant role in its psychoactive effects. Some of the short-term physical effects of cannabis use include increased heart rate, dry mouth, reddening of the eyes, a reduction in intraocular pressure, muscle relaxation, and a sensation of cold or hot hands and feet and/or flushed face. Electroencephalography or EEG shows somewhat more persistent alpha waves of slightly lower frequency than usual. Cannabinoids produce a marked depression of motor activity via activation of neuronal cannabinoid receptors belonging to the CB1 subtype. Peak levels of cannabis-associated intoxication occur approximately 30 minutes after smoking it and last for several hours. The total short-term duration of cannabis use when smoked is based on the potency, method of smoking, e.g. whether pure or in conjunction with tobacco, and how much is smoked. Peak levels of intoxication typically last several hours. Duration. When taken orally, the psychoactive effects take longer to manifest and generally last longer, typically lasting for 4–10 hours after consumption. Very high doses may last even longer. Also, oral ingestion use eliminates the need to inhale toxic combustion products created by smoking and therefore negates the risk of respiratory harm associated with cannabis smoking. The areas of the brain where cannabinoid receptors are most prevalently located are consistent with the behavioral effects produced by cannabinoids. Brain regions in which cannabinoid receptors are very abundant are the basal ganglia, associated with movement control, the cerebellum, associated with body movement coordination, the hippocampus, associated with learning, memory, and stress control, the cerebral cortex, associated with higher cognitive functions, and the nucleus accumbens, regarded as the reward center of the brain. Other regions where cannabinoid receptors are moderately concentrated are the hypothalamus, which regulates homeostatic functions, the amygdala, associated with emotional responses and fears, the spinal cord, associated with peripheral sensations like pain, the brain stem, associated with sleep, arousal, and motor control, and the nucleus of the solitary tract, associated with visceral sensations like nausea and vomiting. Smoked. Experiments on animal and human tissue have demonstrated a disruption of short-term memory formation, which is consistent with the abundance of C receptors on the hippocampus, the region of the brain most closely associated with memory. Cannabinoids inhibit the release of several neurotransmitters in the hippocampus such as acetylcholine, norepinephrine, and glutamate, resulting in a major decrease in neuronal activity in that region. This decrease in activity resembles a temporary hippocampal lesion. In vitro experiments, THC at extremely high concentrations, which could not be reached with commonly consumed doses, caused competitive inhibition of the AKE enzyme and inhibition of beta-amyloid peptide aggregation, implicated in the development of Alzheimer's disease. Compared to currently approved drugs prescribed for the treatment of Alzheimer's disease, THC is a considerably superior inhibitor of A aggregation, and this study provides a previously unrecognized molecular mechanism through which cannabinoid molecules may impact the progression of this debilitating disease. Oral. Neurological effects. Effects on driving. While several studies have shown increased risk associated with cannabis use by drivers, other studies have not found increased risk. Cannabis usage has been shown in some studies to have a negative effect on driving ability. The British Medical Journal indicated that drivers who consume cannabis within 3 hours of driving are nearly twice as likely to cause a vehicle collision as those who are not under the influence of drugs or alcohol. In Cannabis and Driving, a review of the literature and commentary, the United Kingdom's Department for Transport reviewed data on cannabis and driving, finding cannabis impairs driving behavior. However, this impairment is mediated in that subjects under cannabis treatment appear to perceive that they are indeed impaired. Where they can compensate, they do. For example, effects of driving behavior are present up to an hour after smoking but do not continue for extended periods. The report summarizes current knowledge about the effects of cannabis on driving and accident risk based on a review of available literature published since 1994 and the effects of cannabis on laboratory-based tasks. The study identified young males, amongst whom cannabis consumption is frequent and increasing, and in whom alcohol consumption is also common, as a risk group for traffic accidents. The cause, according to the report, is driving inexperience and factors associated with youth relating to risk-taking, delinquency and motivation. These demographic and psychosocial variables may relate to both drug use and accident risk, thereby presenting an artificial relationship between use of drugs and accident involvement. Kelly, Dark, and Ross show similar results, with laboratory studies examining the effects of cannabis on skills utilized while driving showing impairments in tracking, attention, reaction time, short-term memory, hand-eye coordination, vigilance, time and distance perception, and decision-making and concentration. An EMCDA review concluded that the acute effect of moderate or higher doses of cannabis impairs the skills related to safe driving and injury risk, specifically attention, tracking and psychomotor skills. In their review of driving simulator studies, Kelly et al. Conclude that there is evidence of dose-dependent impairments in cannabis-affected drivers' ability to control a vehicle in the areas of steering, headway control, speed variability, car following, reaction time and lane positioning. The researchers note that even in those who learn to compensate for a drug's impairing effects, substantial impairment in performance can still be observed under conditions of general task performance. A 2012 meta-analysis found that acute cannabis use increased the risk of an automobile crash. An extensive 2013 review of 66 studies regarding crash risk and drug use found that cannabis was associated with minor, but not statistically significant increased odds of injury or fatal accident. The estimated fatal crash odds for cannabis were lower than opiates, anti-anxiety medications, zopiclone, cocaine, and amphetamines. The estimated injury odds for cannabis were lower than antihistamines, penicillin, anti-anxiety meds, antidepressants, anti-asthmatics, zopiclone, cocaine, and opiates. The study concluded, by and large, the increase in the risk of accident involvement associated with the use of drugs must be regarded as modest, compared to the huge increase in accident risk associated with alcohol, as well as the high accident rate among young drivers. The increases in risk associated with the use of drugs are surprisingly small. A report from the University of Colorado, Montana State University, and the University of Oregon found that on average, states that have legalized medical cannabis had a decrease in traffic-related fatalities by 8–11%. The researchers hypothesized it's just safer to drive under the influence of marijuana than it is drunk. Drunk drivers take more risk, they tend to go faster. They don't realize how impaired they are. People who are under the influence of marijuana drive slower, they don't take as many risks. Another consideration, they added, was the fact that users of marijuana tend not to go out as much. In the largest and most precisely controlled study of its kind carried out by the U.S. Department of Transportation's National Highway Traffic Safety Administration to research the risks of cannabis and driving, it was found that other studies that measure the presence of THC in the driver's blood or oral fluid, rather than relying on self-report, tend to have much lower elevated crash risk estimates. Likewise, better controlled studies have found lower elevated crash risk estimates. The study found that after adjusting for age, gender, race, and alcohol use, drivers who tested positive for marijuana were no more likely to crash than those who had not used any drugs or alcohol prior to driving. The study, however, cautions that these results do not indicate that drug use by drivers is risk-free. Short-term effects on the cardiovascular system can include increased heart rate, dilation of blood vessels, and fluctuations in blood pressure. There are medical reports of occasional heart attacks or myocardial infarction, stroke, and other cardiovascular side effects. Marijuana's cardiovascular effects are not associated with serious health problems for most young, healthy users. Researchers reported in the International Journal of Cardiology, marijuana use by older people, particularly those with some degree of coronary artery or cerebrovascular disease, poses greater risks due to the resulting increase in catecholamines, cardiac workload, and carboxyhemoglobin levels, and concurrent episodes of profound postural hypotension. Indeed, marijuana may be a much more common cause of myocardial infarction than is generally recognized. In day-to-day practice, a history of marijuana use is often not sought by many practitioners, and even when sought, the patient's response is not always truthful. A 2013 analysis of 3,886 myocardial infarction survivors over an 18-year period showed no statistically significant association between marijuana use and mortality. A 2008 study by the National Institutes of Health Biomedical Research Center in Baltimore found that heavy, chronic smoking of marijuana changed blood proteins associated with heart disease and stroke. A 2000 study by researchers at Boston's Beth Israel Deaconess Medical Center, Massachusetts General Hospital and Harvard School of Public Health found that a middle-aged person's risk of heart attack rises nearly five-fold in the first hour after smoking marijuana, roughly the same risk seen within an hour of sexual activity. Cannabis arteritis is a very rare peripheral vascular disease similar to Buerger's disease. There were about 50 confirmed cases from 1960 to 2008, all of which occurred in Europe. A confounding factor in cannabis research is the prevalent usage of other recreational drugs, especially alcohol and nicotine. Such complications demonstrate the need for studies on cannabis that have stronger controls, and investigations into alleged symptoms of cannabis use that may also be caused by tobacco. Some critics question whether agencies doing the research make an honest effort to present an accurate, unbiased summary of the evidence, or whether they cherry-pick their data to please funding sources which may include the tobacco industry or governments dependent on cigarette tax revenue. Others caution that the raw data, and not the final conclusions, are what should be examined. The Australian National Household Survey of 2001 showed that cannabis in Australia is rarely used without other drugs. 95% of cannabis users also drank alcohol, 26% took amphetamines, 19% took ecstasy, and only 2.7% reported not having used any other drug with cannabis. While research has been undertaken on the combined effects of alcohol and cannabis on performing certain tasks, little research has been conducted on the reasons why this combination is so popular. Evidence from a controlled experimental study undertaken by Lucas and Orozco suggests that alcohol causes THC to be absorbed more rapidly into the blood plasma of the user. Data from the Australian National Survey of Mental Health and Wellbeing found that 3/4 of recent cannabis users reported using alcohol when cannabis was not available. This suggests that the two are substitutes. Studies on cannabis and memory are hindered by small sample sizes, confounding drug use, and other factors. The strongest evidence regarding cannabis and memory focuses on its temporary negative effects on short-term and working memory. In a 2001 study looking at neuropsychological performance in long-term cannabis users, researchers found some cognitive deficits appear detectable at least 7 days after heavy cannabis use but appear reversible and related to recent cannabis exposure rather than irreversible and related to cumulative lifetime use. On his studies regarding cannabis use, lead researcher and Harvard professor Harrison Pope said he found marijuana is not dangerous over the long term, but there are short-term effects. From neuropsychological tests, Pope found that chronic cannabis users showed difficulties, with verbal memory in particular, for at least a week or two after they stopped smoking. Within 28 days, memory problems vanished and the subjects were no longer distinguishable from the comparison group. Researchers from the University of California, San Diego School of Medicine failed to show substantial, systemic neurological effects from long-term recreational use of cannabis. Their findings were published in the July 2003 issue of the Journal of the International Neuropsychological Society. The research team, headed by Dr. Igor Grant, found that cannabis use did affect perception, but did not cause permanent brain damage. Researchers looked at data from 15 previously published controlled studies involving 704 long-term cannabis users and 484 non-users. The results showed long-term cannabis use was only marginally harmful on the memory and learning. Other functions such as reaction time, attention, language, reasoning ability, perceptual and motor skills were unaffected. The observed effects on memory and learning, they said, showed long-term cannabis use caused selective memory defects, but that the impact was of a very small magnitude. A study at Johns Hopkins University School of Medicine showed that very heavy use of marijuana is associated with decrements in neurocognitive performance even after 28 days of abstinence. The feeling of increased appetite following the use of cannabis has been documented for hundreds of years, and is known colloquially as the munchies in the English-speaking world. Clinical studies and survey data have found that cannabis increases food enjoyment and interest in food. Scientists have claimed to be able to explain what causes the increase in appetite, concluding that endocannabinoids in the hypothalamus activate cannabinoid receptors that are responsible for maintaining food intake. Rarely, chronic users experience a severe vomiting disorder, cannabinoid hyperemesis syndrome, after smoking, and find relief by taking hot baths. Endogenous cannabinoids were discovered in cow's milk and soft cheeses. Endocannabinoids are also found in human breast milk. It is widely accepted that the neonatal survival of many species is largely dependent upon their suckling behavior, or appetite for breast milk, and recent research has identified the endogenous cannabinoid system to be the first neural system to display complete control over milk ingestion and neonatal survival. It is possible that cannabinoid receptors in our body interact with the cannabinoids in milk to stimulate a suckling response in newborns so as to prevent growth failure. Most microorganisms found in cannabis only affect plants and not humans, but some microorganisms, especially those that proliferate when the herb is not correctly dried and stored, can be harmful to humans. Some users may store marijuana in an airtight bag or jar in a refrigerator to prevent fungal and bacterial growth. The fungi Aspergillus flavus, Aspergillus fumigatus, Aspergillus niger, Aspergillus parasiticus, Aspergillus tamarii, Aspergillus sulphureus, Aspergillus ripens, Mucor alice, Penicillium chrysogenum, Penicillium italicum, and Rhizopus nigrans have been found in moldy cannabis. Aspergillus mold species can infect the lungs via smoking or handling of infected cannabis and cause opportunistic and sometimes deadly aspergillosis. Some of the microorganisms found create aflatoxins, which are toxic and carcinogenic. Researchers suggest that moldy cannabis should thus be discarded to avoid these serious risks. Mold is also found in smoke from mold-infected cannabis, and the lungs and nasal passages are a major means of contracting fungal infections. Levitz and Diamond suggested baking marijuana in home ovens at 150 degrees Celsius, for 5 minutes before smoking. Oven treatment killed Canidia of A. fumigatus, A. flavus and A. niger, and did not degrade the active component of marijuana, tetrahydrocannabinol. Cannabis contaminated with Salmonella mucin was positively correlated with dozens of cases of salmonellosis in 1981. Thermophilic actinomycetes were also found in cannabis. Exposure to marijuana may have biologically based physical, mental, behavioral, and social health consequences and is associated with diseases of the liver, lungs, heart, and vasculature according to a 2013 literature review by Gordon and colleagues. The association with these diseases has only been reported in cases where people have smoked cannabis. The authors cautioned that evidence is needed, and further research should be considered, to prove causal associations of marijuana with many physical health conditions. Cannabis use disorder is defined in the fifth revision of the Diagnostic and Statistical Manual of Mental Disorders as a condition requiring treatment. Several drugs have been investigated in an attempt to ameliorate the symptoms of stopping cannabis use. Such drugs include bupropion, D-valproex, nefazodone, lofexidine, and dronabinol. Of these, dronabinol has proven the most effective. Cannabis consumption in pregnancy might be associated with restrictions in growth of the fetus, miscarriage, and cognitive deficits in offspring based on animal studies. However, there is limited evidence for this in humans at this time. A 2012 systematic review found although it was difficult to draw firm conclusions, there was some evidence that prenatal exposure to cannabis was associated with deficits in language, attention, areas of cognitive performance, and delinquent behavior in adolescence. A report prepared for the Australian National Council on Drugs concluded cannabis and other cannabinoids are contraindicated in pregnancy as it may interact with the endocannabinoid system. Cardiovascular effects. Combination with other drugs. Memory and learning. Appetite. Pathogens and microtoxins. Fungi. Bacteria. Long-term effects. Effects in pregnancy.